7 levels of AI robots. Level 1. Early industrial robots. The first industrial robot, UNIMATE, started work at General Motors in the 1960s. Built by George Devol and Joseph Engelberger, it was a 4,000-pound metal arm that followed simple, step-by-step commands stored on magnetic tape. UNIMATE lifted hot metal, welded car parts, and moved heavy objects, jobs too dangerous for humans. These early robots ran on hydraulics, which made them powerful but messy and hard to maintain because oil often leaked. Despite this, they worked non-stop and never got tired, helping factories make cars faster and safer. In 1969, Victor Scheinman created the Stanford Arm, the first robot powered by electricity and controlled by a computer. It was light, clean, and accurate, even assembling a Ford Model T water pump by 1974. These early machines became the foundation of modern automation, changing how factories around the world worked forever. Level 2. Mobile AI robots with decision-making. In the 1960s, SRI International built a robot called Shakey, the first machine that could move and think on its own. It used sensors, a camera, and a program called strips to understand its surroundings and plan actions. If Shakey was told to move across a room or push a box, it could figure out how to do it by looking around, making a plan, and carrying it out. Shakey had a camera for vision, metal whiskers as touch sensors, and a rangefinder to measure distance. It was slow and moved in a shaky way, but it could solve problems and recover from mistakes, something no other robot could do before. Earlier robots only followed preset instructions, but Shakey made decisions based on what it saw. This idea, robots learning and planning, became a key concept in modern robotics. Even earlier, in 1949, William Gray Walter built small turtle-shaped robots that could move toward light and return to their chargers. These little machines were the first examples of autonomous navigation, long before today's self-driving cars. Level 3. Social humanoid robots. In 2016, Sophia, a lifelike robot created by Hanson Robotics, was activated. Sophia can talk, make facial expressions, and recognize people. In 2017, Saudi Arabia made history by granting Sophia citizenship, the first for any robot. Sophia has 74 moving parts and cameras that help her see and respond to emotions. Her speech is powered by AI systems like GPT-4. In 2021, Sophia even sold a self-portrait for nearly $700,000, showing that robots can also create art. Sophia travels the world, speaks at events, and is designed to help people, especially the elderly, through conversation and companionship. Level 4. Precision medical robots. The Vinci surgical system, made by Intuitive Surgical, is one of the most advanced medical robots in the world. It helps doctors perform surgeries through very small cuts, making the process safer and recovery faster. The system was first used in the early 2000s and by 2012 had been used in over 200,000 surgeries, including hysterectomies and prostate operations. By 2024, Vinci Systems performed over 2.6 million procedures worldwide, generating billions in revenue. The latest version, Vinci 5, has more than 150 design upgrades and uses 10,000 times more computing power than before. It gives surgeons better control and precision. The robot's force feedback feature helps reduce pressure on human tissue by up to 43%, lowering the risk of damage. The surgeon sits at a console viewing a 3D image from a high-definition camera inside the patient. Robotic arms hold surgical tools and the doctor moves them using hand and foot controls. The robot copies the surgeon's actions with perfect steadiness. The system's uptime exceeds 99% thanks to real-time monitoring and data tracking. Researchers at Johns Hopkins University trained Vinci robots using imitation learning, feeding them hundreds of surgery videos. These robots learn to perform surgical tasks almost as accurately as human doctors, proving that medical robots can learn by observation instead of traditional programming. Level 5. Mass-market humanoid robots. Tesla's Optimus, also called the Tesla Bot, is designed to work alongside humans in factories and homes. Standing 5 feet 8 inches tall and weighing 125 pounds, it can lift 45 pounds and perform repetitive or dangerous tasks. By 2025, Tesla plans to use around 5,000 Optimus robots in its factories. The Optimus version 3 version looks more human-like, with 22 flexible joints in its hands for better control. Other companies like Figure and UBTech are also creating similar humanoids. UBTech's Walker S1 has already received hundreds of orders, showing that the era of human-shaped working robots is rapidly approaching. Level 6. AI-powered autonomous learning. In 2025, China invested approximately 730 billion yuan, roughly $100 billion, to advance AI and robotics in smart manufacturing and healthcare. Starting in September 2025, China mandated labeling of AI-generated content to ensure transparency and public trust in these technologies. In January 2025, Stargate LLC was formed as a joint venture of OpenAI, SoftBank, Oracle, and MGX, who announced plans to invest $500 billion in AI infrastructure in the United States by 2029. These investments accelerate AI robot development worldwide. Boston Dynamics Atlas has long set the public standard for dynamic agility. Vaults, jumps, and rapid balance recovery remain Atlas's calling cards. In 2024 through 2025, Boston Dynamics emphasized an all-electric Atlas that continues to demonstrate advanced dynamic behaviors and serves as a technical benchmark for high-performance balance and locomotion. Modern robots incorporate machine learning directly. Systems improve through experience without new programming. In 2011, an NLP computer programmed to answer questions named Watson, created by IBM, won Jeopardy against 2 former champions in a televised game. Watson demonstrated AI capabilities in complex reasoning tasks. In 2017, Facebook programmed 2 AI chatbots to converse and learn how to negotiate, but as they went back and forth, they ended up foregoing English and developing their own language, completely autonomously. AI systems create unexpected solutions during learning processes. In 2018, a Chinese tech group called Alibaba's Language Processing AI beat human intellect on a Stanford reading and comprehension test. Robots now process visual information in real time. In 2021, OpenAI developed DALL-E, which can process and understand images enough to produce accurate captions, moving AI one step closer to understanding the visual world. Computer vision allows robots to identify objects and navigate complex environments. Level 7. General-purpose intelligent robots. By 2025, Tesla had built over 1,000 Optimus robots, using them in factories to move materials. However, they still worked slower than humans and needed improvements in heat control, battery life, and strength. Elon Musk plans to send an Optimus robot to Mars in 2026, where it must make decisions on its own because of long communication delays. These robots are early steps toward true general-purpose intelligence machines that can think and adapt like humans. Today's robots like Digit, Figure, and Apptronic can do specific tasks but still lack human flexibility. The next generation must learn new jobs quickly and handle surprises without reprogramming. Scientists are working toward artificial general intelligence, AGI, robots that understand context, share knowledge across tasks, and make independent choices. Progress is steady, but no robot yet matches the creativity and adaptability of the human mind.